This video is about the discriminant. And before we get into any algebra, we need to have a little word study here. To discriminate is a verb, and it has multiple meanings. And probably the meaning that you're most familiar with is the second one here, which is to make an unjust or prejudicial distinction in the treatment of different categories of people, like racial discrimination. But to discriminate also has a secondary, more positive meaning, and it's to recognize a distinction or to differentiate, which is what we're going to be doing today. And just an example, some people are said to have discriminating taste, which means they know something that's very, very nice, very, very expensive, versus something that is not so great, cheap. So, discriminate. We're going to be finding the discriminant of a quadratic equation. So, we've already learned about the quadratic formula in the previous video. Embedded within the quadratic formula is an expression that can discriminate the zeros or the roots. Remember, zeros are the same thing as x-intercepts. So zeros, roots, x-intercepts, they all are exactly the same thing. They're all representing the same thing. So this is the whole quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Well, this part that I have highlighted in green, b squared minus 4ac, it is the discriminant. It discriminates the roots. So we've got 3 examples here of one of each case so we can see how this works. So first of all, case 1, what happens when the discriminant is greater than 0? D is greater than 0. So we have y equals negative 4x squared minus 8x plus 1. We're going to go ahead and solve this using the quadratic formula. But before we do, let's take a look at the graph of this particular equation. So let's take a look at this graph. I'm going to plug it in my graphing calculator so you can take a look. So y equals negative 4x squared minus 8x plus 1. So when we graph this particular quadratic equation, we can see very clearly that there are 2 x-intercepts. They definitely exist. So if I were to try to calculate them, which you can on this handy dandy calculator, I hit the wrong button. Calculate up top. Calculate. I want to calculate a 0. So if I want to calculate a 0, I need to get to the left of one of those points. So there's a left boundary. Then I'll get to the right. There's a right boundary. So I have a 0, an x-intercept at negative 2.118. So there's one of them. I can find the other one. So let's calculate a 0. So let's get to the left of the other one and then to the right of the other one. And my other 0 or x-intercept, it looks like it's at 0, 0, but it's not. It's actually at 0.118. So we're going to see how we can discriminate the roots. But just remember, we know that they exist. We know that they are real. We can see them with our eyes. They are definitely real. So first of all, we need A, B, and C. A is negative 4, B is negative 8, and C is 1. So remember, we're not exactly solving this. All we're after is the discriminant in order to discriminate the solutions and see if they exist. So all we're after is b squared minus 4 times a times c. So b squared, that is negative 8 squared. And remember, anytime that you're going to plug anything into your calculator, it needs to be in parentheses. minus 4 times A times C. Now, personally, I wouldn't say negative 8 squared. I would just go ahead and say 64. That's the easiest thing. After that, we've got negative 4 times negative 4 times 1, that's 16, and 64 plus 16 is 80. So, here's the deal. The discriminant is 80, and 80 is bigger than 0. And if your discriminant is greater than 0, you know that you have two real roots. That's how we can discriminate the roots, by observing what the discriminant is. Let's see case 2. Case 2 is when we have a discriminant equal to 0. So what does that look like in terms of a graph? Let's plug in this quadratic equation. So y equals x squared plus 6x plus 9. In this particular equation, we only have one 0, one x-intercept. And you can see that that one x-intercept is the vertex. So if your vertex just happens to sit on top of the x-axis, then you know that we only have one root. Why? Because it's only touching the x-axis one time. So let's find out. A is 1. Remember, that's a 1 that is in front of that x squared. B is 6. C is 9. The discriminant is b squared minus 4ac. So b squared, b is 6, b squared is 36, minus 4 times 1 times 9. 4 times 9 is 36. 36 minus 36 is 0. 0 is equal to 0. So when the discriminant is equal to 0, we have exactly one real root. And let's calculate what that root is. So calculate. Let's calculate the 0 here. And let's get to the left of it. And we'll get to the right of it, which basically is allowing the calculator only to look in that one slice of the domain. And it's asking us to make a guess. Yes, please do. My 0 is at negative 3. Negative 3 is 0. So when the discriminant is equal to 0, we have exactly one real root. Last problem. The discriminant is less than 0. Before we calculate the discriminant, let's take a look at the graph. So if we plug this in to graph it, so 4x squared minus 10x plus 8. If we plug this in to graph it, here it comes. Will this parabola ever be intersecting the x-axis? No, it will not. Its minimum value, and we can calculate a minimum value on my graphing calculator. So there's a left, or nope, that was a right. Yep, okay, that was a left. Let's get to the right of it. So we're calculating a minimum here. That minimum value is at 1.75. So over 1.25, up 1.75. Here's a better picture of it. So we have a minimum value at 1.75. So no way, no time, no ever is this parabola going to intersect the x-axis. Therefore, I know that my zeros really do not exist in the real number system. So A is 4, B is negative 10, C is 8. So what happens when we plug in these values into the formula for the discriminant, we're going to get a D value that is less than 0. So B is negative 10, B squared is 100, minus 4 times A times C. So we end up with 100 minus, and this is 32 times 4. 32 times 4 is 128. And 100 minus 128 is negative 28. Now, here's the reason I know that we have non-real roots. Remember, the discriminant is the part of the quadratic formula that's actually underneath a radical. So, if I try to take the square root of a negative number, is there anything that we can multiply to itself and get a negative number? No, not in the real number system. Therefore, I know that since my discriminant is less than 0, that my roots are non-real. They actually are imaginary, and we will learn all about those in Algebra 2. So, reviewing quickly. If the discriminant is greater than 0, you will have 2 real roots. Why? Because the square root of 80 is a real number. If the discriminant is equal to 0, we will have exactly 1 real root. Why? Because the solution, or the root, or the 0 is the same thing as the vertex if you get 0. And lastly, case 3, if your discriminant is less than 0, you're going to get non-real roots, 2 non-real roots. Why? Because we cannot take the square root of negative 128 and it exists in the real number system. So you can see a whole graphic on the Chapter 8 Google site that will remind you of these 3 cases, but that is all you need to know